Thanks for the introduction. Uh, this talk is going to be about shifting left for continuous quality in data. And if you're here for this talk, you're in the right place. I'm glad to see quite a few of you here, and I'm assuming you are interested in testing and testing for data projects. So my name is Avinash Padmanabhan, and I'm currently employed with Intuit. Before that, in my professional work life, I have been employed with Gap.com, with AT&T, and before that with Citrix. For most of these projects, I have worked testing web services and a bit of UI. But for the last 3 years or so, I have been testing in some shape or form data projects at Intuit. So just a quick show of hands, since this is the first post-lunch session. I'm hoping you guys don't fall off to sleep. So who of you are data engineers, SQL developers? How many of you can say yourself? Okay, cool. And how many of you are data testers? Oh, just one. Okay. So anyway, so my simple goal for this presentation is that my simple goal with this presentation is that I explain to you what I understand by what I mean by shift left testing, and then my expectation is that you walk out of this presentation with the understanding that automated unit and functional testing is very much possible even for data projects, and in fact should be practiced as much as possible. There's no reason why data projects should be treated any differently from, say, a UI testing project or a web services testing project. Sorry. So what do I mean by shift left testing? So when you talk about shift left testing, or when you look for shift left testing on Google, you'll see a wide variety of definitions. But the one I will go with is the one which is mentioned here is you start testing as early as practical. So the primary goal for this being that the sooner you find issues, the better it is for you in terms of rework, in terms of avoiding delays, and in terms of reducing the churn. So in the end product is that you deliver something which is more of a quality product and the release goes off smoothly. So what will be covered as part of this presentation? I'll be giving you a very high-level overview of the data pipeline at Intuit. I'll be talking about testing ETLs, why you should be testing and validating your ETLs. I'll be talking about our testing journey, the different aspects of our testing journey, how we started and where we are at currently. Then I'll be talking about what I call unit testing and integration testing for the projects we have at Intuit. In the next half of the presentation, I'll be talking about how we can use containers, specifically Docker, to shift left for continuous quality. I'll be giving you an overview of the Docker ecosystem. So I'll be going over some of the features of Docker, like Docker networking, volumes, and a tool called Docker Compose. And then finally, I'll be talking about how we use Docker to automate our unit and functional tests. So let's get started. So as promised, this is a high-level overview of the data pipeline Intuit. On the left, you'll see, this is pretty traditional, so there are no surprises here. But on the left, you'll see some transactional databases which correspond to each of the products we have at Intuit, like accounting, payments, and payroll. We have some enterprise databases like billing and Salesforce. And then we have third-party data like SEO data, social data, or data from our different vendors. All this data gets moved via an ingestion process into the data lake, which for us is a Hadoop cluster. And then data from this Hadoop data lake is then moved again via the data mart ingestion process to the different data marts we have. The data mart itself is based on a Vertica cluster. The data movement between source, the data lake, and the data mart is happening via jobs scheduled in Tidal, which is our workflow scheduler. And then business visualization and reporting happens via a mix of Tableau and ClickView dashboards. Our customers in this case are business analysts who look to our data to actually get more insights into our customers, and then also business leaders who look to our data to actually make decisions. So before I actually start with the meat of my presentation, I'd like to show you a chart of a Google Trends chart. So what Google Trends is a tool provided by Google which allows you to input a search term, and then it tells you how the search term has performed over the last few years. So the search term I have put in here is a search term for big data. And as you can see, it's no surprise here we are in the Strata plus Hadoop world, which is a big data conference. So it's no surprise that big data has shown a lot of interest over the last few years. It seems to be leveling off a bit, at least lately in the last year or so, but in general, it has seen an upward trend. But what is surprising, what is intriguing to me is this when I actually plot big data versus the trends for ETL testing and big data testing, you see that the trends are pretty much flat. Big data has been growing over time, but not so much the searches for testing. So why is that the case? I really don't have any solid answers here. So I'm looking to you guys to see if you have any clues, any take on why this might be. Anyone? Yeah, go for it. Right. Right. Yeah, so I think I'll touch on one of those points. So for when I started actually testing, the common concerns I heard was that it's pretty time consuming. So it was just easier to log on to the console, to log on to any SQL client and run your queries, get the results, and start testing it that way. And then testing edge cases or corner cases was hard because setting up dummy data is hard. And then, as with any software development project, this feature should have gone out yesterday. So the common thing with most developers is that they're in a time crunch, and the first thing that goes out of the door is whether they should have actually tested the code and delivered it to QE or to source control or whatever. And the other more valid concerns, in my opinion, are there are no open source mature testing frameworks. So I have tested with web services projects, I have tested UI projects, and then you have more than a multitude of choices for you to choose from and to use, but not so with data. I don't understand why, because data warehouses have been around a while, so I'm not sure why. And then the data domain is different from web services or from UI for any Java development project. We have different database vendors, we have different SQL implementations, so there's not one testing tool which encompasses everything. But we should still be testing, unit testing, automated functional testing. We should still be having it for our projects as well. So first and foremost is it makes you a better developer. As you start unit testing your own code, as you start figuring out how your customer is going to use your your data, how QE is going to test your ETL code, you start incorporating all these practices into your day-to-day development, and it makes you a better developer in the long run. Most importantly, it makes your customers happy, it makes your analysts happy. So letting customers find issues is a really long dev life cycle. So how did we start testing? So we started testing also pretty predictably. This is our testing journey. So how did we start testing? It was pretty predictable. So we started testing manually. As I mentioned before, it was pretty easy to do. Just log on to the gateway node, fire up a SQL client, run your queries, get the results back, and do your testing that way. But the cons of this approach, as you might imagine, are pretty long. It's not scalable. It's definitely time consuming. And if you got started the way we got started with testing Hive queries, you know that they're notoriously slow. So just waiting for one query to run, getting the result back, and then repeating the same process over and over again is pretty painful. The next step up for us was wrapping whatever we were writing as manual tests in shell scripts. So this was, again, the advantages of this was it was pretty easy to get started if you knew. I mean, most of us know some kind of shell scripting. So it was easy to just wrap your SQL queries in these shell scripts and start automating them that way. And especially if you started making some basic comparisons or assertions against the results of these queries, you made it somewhat automated as well. The downsides of this approach is that it's still shell scripting, which is not the easiest language to write your tests in. And then it is not extensible. So if you use any mature testing framework, you have built-in assertions, you have built-in reporting, you can easily plug it into CI and CD. And most of these things are either not possible or difficult with shell scripting. The next step for us was, next phase in our journey was moving the shell script based tests into something where we use Java and TestNG. So what we used to, in this and all the previous approaches, what we used to do was we used to rely on data which is already existing in test or pre-prod environments. So we used to assume that there was some source data, we had some ETL scripts, and there was some raw data. And we used to assume that all these things have already happened, that the ETL script has been run, the source data has been transformed into raw data. And then our test used to just run queries against the source data and the target data, and either run data parity comparisons or transformation checks or aggregation checks. So this was how we used to do testing. And even now, we have some variation of this for our integration tests, where we depend on data which is already existing. But again, over the long run, as we use more and more of these kind of test cases, we moved our shell scripts to Java and TestNG based tests. We realized that it was difficult. It got difficult to test edge cases, in that since you're testing with pre-existing data, it becomes more difficult to actually test your edge cases or corner cases. And then it becomes hard to read and maintain. So if you notice, we have a SQL query wrapped inside a TestNG test here. So this is pretty long, and this is actually an example of a pretty small query, but we used to have queries to ran pages long, and then we used to wrap them in Java tests, and this became hard to read and maintain. And finally, in terms of developer adoption, one of the goals we had when we started developing the test framework was that developers would have an equal hand in writing and maintaining their own test cases. But because we built a test framework which was written in Java and TestNG, and which not many SQL developers or ETL developers are familiar with, we found that the developer adoption was not as much as we had hoped for. So which brought us to the next phase in our testing journey. This was still TestNG and Java based. But what we started doing differently was, instead of wrapping our tests in Java and TestNG, SQL queries in Java and TestNG itself, we actually started writing our tests within ETL files. So this was actually pretty useful for us in that. So we had a custom SQL test runner, which would parse as ETL file just like any other ETL file. But once it came across a SQL comment with the @test annotation, then it would parse that as a test. So it will parse the JSON blob. So in the first case, it would parse the name and the vSQL file, which is in this case the Vertica SQL file, and then it would run this ETL. In the next instance, it would parse the name, the query, and the expectation. So it would run the query and parse the expectation and match the result of the query with the expectation. So this gave us, this is pretty neat, and this gave us quite a bit of advantages. The first one being that it was easier to understand the ETL flow itself now. So just by going through the ETL script and going through the test cases which are written for those ETL scripts, you could understand what the ETL script was doing. The next thing was that the SQL query and the assertions were being paired together. So it was easy to know itself what the test case was doing. And then finally, in terms of a developer adoption, developers did not have to actually learn a new programming language. They didn't have to learn Java. They didn't have to learn Python. All they had to do was write these JSON blobs and wrap it inside SQL comments. So that way, when actually a SQL test runner would run against the ETL scripts, it would parse these tests and run them as TestNG tests. So the other thing we started doing in this phase of our testing efforts, was that we started requiring developers to install local VMs with the required databases, which in our case was Vertica. So Vertica comes with its own VMware edition, so you can actually set up Vertica as a community edition within your local environment. So we started requiring developers to do that, just so that they actually run these tests locally before pushing the tests out to source control or to shared environments. However, this had some downsides, even though it was good, not downsides, but this had some things we needed to address. The first thing being that because we were requiring the developers to run these tests locally, we were asking them to set up fake test data or seed test data for the tests. And then other thing we were requiring them to do is set up the VMs, like I mentioned. So, and the VM setup for at least for Vertica was not difficult, but it's not trivial. So this was a hurdle which not many developers crossed. So as a result, that even though we had a framework which the developers could use, we still were not getting enough developer adoption. We still have the problem where we need to fake test data, but we are trying to address the local setup of required databases. And that's where I come to, the next half of my presentation, which is Docker. Docker is a form of Linux container. How many of you guys have used Docker? Or cool, I use it for data projects. Cool, awesome. I had showed you this chart earlier in the first half of the presentation where I have plotted big data versus testing trends. What gets really interesting is if I actually plot Docker in the same mix. So you see Docker has really taken off in interest even versus big data. So what exactly is Docker for people who have not used it? Docker is a form of operating system virtualization in that it is very different from setting up a local VM. While VM gives you complete isolation, Docker still shares the host Linux kernel. But what it does provide you is it provides you isolated user space, it provides you isolated view of the file system, and then also an isolated view of the processes. So in that, even though it doesn't give you complete isolation, it still gives you some other advantages in terms of latency. So setting up a Docker container is really fast compared to setting up a VM in your local environment. The other advantages Docker provides you is the ability to package your dependencies and your application together. So in one file, which is called a Docker file. So if you build a Docker image based on this Docker file, then it becomes instantly shareable and portable. And Docker has really matured in the last couple of years or so. So you have Docker Hub, which is the official Docker registry. So Docker Hub is to Docker image is what GitHub is to source code. And then we have other public registries like Amazon EC2 and Google Container Registry. You can also build your own private registry, which Intuit has done. The other important feature which Docker provides you is it allows you to isolate software from hardware. So even though your hardware, Docker host might fail, you can still move the Docker container onto a different host and run it from there. So this is one example of a Docker file where I have packaged. This is for the Hive container I have built. So this is being sourced from Hadoop. And then I have installed Hive on top of that, and I'm installing MySQL as well for the Hive Metastore. So as you see, it is all packaged in one Docker file. When I build a Docker image out of this, then it can be shared and posted anywhere else. The next one is a Docker file for the Vertica image. For this, I'm sourcing the Vertica image from CentOS, but you can use anything else as well. I'm installing Java and I'm installing Maven on top of that. The reason being I want to be able to run my tests in the Vertica container. So I have Java and Maven installed. So, next up is just an overview of the Docker ecosystem architecture. Docker inherently is a client-server application. So the Docker client interacts with the Docker server, which is a Docker daemon in this case, and that resides in Docker host via REST API calls. Because it uses REST API calls, you can use any other client. You don't have to rely on the Docker client. So the way to interact with Docker is via the client. So say you want to run a Docker Ubuntu image, you would just do a Docker run Ubuntu. What the client would do is it would make the query to the Docker server. The Docker server would then go into the public registry into your local registry first and see if there is an image already existing. If not, it will go to the public registry and pull that image, and it will then run the container based on the image you have pulled. So the way to think about containers and images is the way you would think about classes and instances in object-oriented programming. So a container is an instance of an image. You can add other things on top of the containers, but a container is sourced from an image. And the other tool that Docker provides us is Docker Machine. Docker Machine allows you to manage a Docker host. The Docker host doesn't have to be local. It can even be on the cloud. So it can be on AWS or Azure or DigitalOcean. So Docker machine comes built in with those templates where it can actually manage clients and cloud providers as well. So next up, I'll be talking about some of the features of Docker that make it useful for testing in our case. The first one is Docker volumes. So Docker containers can be started, stopped, removed, killed. So any data which resides within the container at that point of time is actually lost. But if you want to maintain the data beyond the life of the container, that's where you use Docker volumes. Docker volumes allows you to mount or share data between a local file system and the path location within the container. So this way, even though the container is killed or removed, you still have the shared copy on the local file system. The way we use it is we map, so when we download or when we clone our data project locally, we map the location of that data project to a path within the container. So that's how we share data. So when we run actually tests within the Vertica container, the artifacts can be shared with the local file system as well. The next feature I'm going to talk about is Docker networking. So by default, when Docker is installed on a host, it comes with 3 different networks: the bridge, the host, and the none. None, as you might imagine, means there's no network at all. So the Docker container running on the none network is completely private. And host means it has all the privileges as the Docker host itself. So, I'm sorry. So any container which is using the host network has all the privileges as a Docker host. The bridge network is a default. So if you run a container without specifying a network, it uses the bridge network. So what bridge does is it is not completely private, it's not completely isolated. If you expose ports on the bridge network, then you'll be able to interact with the Docker container using those ports. The additional thing Docker allows you to do is it allows you to create your own user-defined networks. How this is useful is that if you have multiple applications in your pipeline, say for example, I have Hive and I have Vertica, and I want to run Hive container and the Vertica container as part of my pipeline. So then I would be creating a user-defined network and making these containers a part of the same network. I'll be creating these containers, making them part of the same user-defined network. So that way, the Hive container and the Vertica container will be able to interact with each other. So the next tool is, which Docker provides us, is Docker Compose. So again, like I mentioned, I have 2 applications in my data pipeline, the Hive and Vertica. So I need to manage these 2 applications as one single entity, and that's where Docker Compose comes in. And Docker Compose allows you to use a single command to manage both these services. So I can just do a Docker Compose up, and it will start up both the services specified in the Docker Compose.yaml file. So this is an example of a Docker Compose file, sorry, where I'm running a Vertica container and I'm running a Hive container. So the Vertica container is sourced from the Vertica image and the Hive container is sourced from the Hive image. I have made a Vertica container dependent on Hive, and all this means in, thank you, thanks Nino. And all this means in Docker terminology is that Hive will get started first and then Vertica. So Docker still does not know of a way to tell you when the container is ready. So what we need to do, and Hive, because it has to launch Hadoop, it has to launch Hive and then create the dummy data within it. It takes a while, and Vertica gets done quickly. So what I have done is, I have in the Vertica launch scripts, I have put in a polling mechanism where it keeps polling Hive to see if data is available in the HDFS location. And if data is available, then Vertica will start pulling data from the Hive HDFS location and then put it in its own Vertica tables. So now we come to the demo part of the presentation. Here is just a simple shell wrapper script where I'm actually running the Hive and the Vertica containers together. If you see, I'm not actually using Docker Compose. I'm using 2 Docker run commands just so that I can show you what Docker Compose does, which is similar to what Docker run is doing. So I'm running a Docker Hive part here. I'm running a Docker Vertica part, and then I'm making them part of the same SVG data network. So this will allow Hive to interact with Vertica on the port 5433 and Vertica to interact with Hive on the port 50070. And after the two containers are launched, sorry, it will start running the tests, and then it will clean up. It will kill and remove the Hive and Vertica containers. So this is a recorded demo. I'm sorry if it's a little hard to read at the end, but what I'm trying to do here is I have the test console on the right will be actually running my tests. I have the two containers, Docker, the Hive Docker container and the Vertica Docker container. I'm just stating the logs in those two containers. So what happens when I launch this demo, when I start the play is it will actually launch these two containers and then it will, so I'm specifying a dataset name here as well. So what this does is it will actually go into a dataset folder, pick up all the ETL files associated with that particular dataset and start running the tests which are embedded within those ETL files. So let me kick it off. So here it launched the two containers. So Hive gets started first. So it's starting Hadoop first. So Hive is pretty slow to start up. Next up will be Vertica. As soon as Hive is active, so Vertica is already done. So as you see some messages here. So I'm just waiting for Hive data to be available. So it's sleeping while Hive starts up and loads data into the Hive tables. So now Hive is loading data using the MapReduce jobs. In the meanwhile, Vertica is still waiting. So now Hive got done, Vertica created a table based on the Hive data, and the tests have started off. So in this case, I have put in very trivial tests within those ETL files like truncation and duplication, but you can as well, using the approach I showed you earlier, you might as well put in more complicated tests and run it this way. So the tests are running against the Vertica container here. And then once the tests get done, the build is marked as a success, and then the Hive and the Vertica containers are removed. So that is the demo part of the presentation. So for us, what is the future work? What is the next work? What are the next steps for us? So like I mentioned, we still have to write a lot of seed scripts. We still have to write a lot of fake data for testing against our local instances. So we need to figure out a good way to do this. So either having some REST service to actually give us data when we need it, or using data dumps from our test or production environments after sanitizing them. And then we do big data testing, but we don't really use big data. So what does that mean for us when we actually start using big data for our own testing efforts? And then the next thing we want to do is we want to start measuring code coverage for our ETL scripts. So we are actually asking developers to write unit tests, write their own unit tests for the code they push to source control. But how do we measure that? How do we measure what code they have written and how much they have actually covered in terms of code coverage? And then finally, as we move into real-time data ingestion, we need to look into running Spark containers within the same Docker container setup we have. So we need to figure out a way to do that. So all this future work in the next at least near to short term. So in conclusion, even though I know manual testing is pretty common for data projects, it doesn't have to be. As I've showed you, this is one approach for doing automated unit testing, automated functional testing for your data projects as well. You might have other approaches, other ideas, but that's fine as long as you have automation available. And then with shift left, you start your testing as early as possible. So one way to do this is to have your local instances running, have your local Docker containers or local VMs running. So that way, before you actually push code out to source control, you're actually testing it properly before pushing it out. And then there's no reason why data projects should have any lesser standards than projects which are like web services or UI or Java development projects. While it might not be straightforward, I think it's still possible to do things we do in other projects. So that is the conclusion. Yeah, and this is my Twitter handle. This is my LinkedIn profile. Feel free to connect with me online after this if you want. I'm open for questions. Any questions? Yeah, go ahead. So it's written in Java. So yeah, it's written in Java and just parses the ETL files, and then whenever it comes across those comments, it will parse them as a test ng test. Yeah, go ahead. Sorry, go ahead. We have these tests are running as part of Jenkins. Yeah. Yes. Yes. Hadoop and Hive. Yeah. Go ahead. Right. So we have the traditional dev and QE setup, but we are also asking developers to start testing their own code as well before pushing it out to QE or before pushing it out to source control. So have their own unit tests in place and not just hand off code to QE without actually testing it. Yeah. Right. We expect the developers to write it. Yeah. Yeah, as the unit. We call that unit testing. Yeah. Any more questions? Cool. Yeah. So we have it's a batch process. Yeah. Yeah. So we have another tool which does that. We have a data parity or data verification tool, which compares the source and target. But I don't think we are doing profiling yet. I don't think that, yeah, we are not doing profiling yet. But we do have verification tools which compare the source data versus target data. But then I think we catch issues. I think the problem is we do run into situations where we catch issues much later, where the data type has changed or something of that sort, and we don't catch that early on. So only when we actually start doing verification, we see those issues. So yeah, that data profiling tool will be a good thing to do. Yeah. Yeah, exactly. So that was one of my future work challenges. So we need to. So the way we are thinking about is we either have some REST service, build a REST service which will give you this dummy data when you query for it when you need it at runtime, or you have data dumps from shared environments like testing or pre-prod environments or production environments. So corner cases you'll still need to seed your own data, yes. But for other test cases, you can use data dumps or these REST services. Any more questions? Cool. Thank you.